In this presentation, I will be talking about the conservation of energy and the electricity. Here we have a basic concept about what is the energy and how it works. Go down 5 bananas and you will have enough energy to swim for about an hour. That's because your body is a complex machine capable to turning one kind of energy into another kind. In this case, you turn the energy of the food into a movement. Cars can pull off the same trick. Using a certain amount of energy, it can transport you a certain distance down the road. What we have here are two examples of machines, the human body and the automobile, that obey one of the most important laws of physics, the conservation of energy. The law of conservation of energy. What it says? The law of conservation of energy states that the total amount of energy in any isolated physical system will remain unchanged with time, although that energy can be transformed into another form of energy. For example, in the previous text, we were changing the energy of the banana into a movement, what it was swimming for an hour. Who discovered the mechanical equivalent of heat? One of the first people to confirm the law of conservation of energy experimentally was the English physicist James Prescott Joule, who used an ingenious bit of apparatus to find what he called the mechanical equivalent of heat. Here we have a peak of the mechanical equivalent of heat. Joule turned the handle, lowering the weights and also moving these paddles which were in the water. So all the energy the weight lost falling down was transformed into heat on the water. It was directly proportional. I mean, if the weights falling down lost 1000 joules, the water gained 1000 joules of energy that was transformed into heat. One type of energy is the electricity. One of the most significant battles of the 19th century was fought to establish the type of electricity that powers our buildings. At the very end of the 1800s, American electrical pioneer Thomas Edison went out his way to demonstrate that the direct current was a better way to supply electrical power than alternating current, a system backed by his arch-rival Nikola Tesla. What is alternating current? Alternating current is an electric current which periodically reverses direction and changes its magnitude continuously with time, in contrast to direct current, which flows only in one direction. Alternating current is the form in which electric power is delivered to business and residents, and it is the form of electrical energy that consumers typically use when they plug kitchen appliances, televisions, fans, and electric lamps into a wall socket. In this picture, we can see how the signal reverses its directions through the positives and negatives. The other type of current is the direct current. What is direct current? Direct current is one directional flow of electric charge. A battery is a prime example of DC power. Direct current might flow through a conductor such as a wire, but can also flow through semiconductors, insulators, or even though a vacuum, as in electron or ion beams. The electric current flows in a constant direction, distinguishing it from alternating current. A term formerly used for this type of current was galvanic current. In this picture, we can see how the current is always on the positives and is not changing his direction like the alternating current was. Inverters. What is an inverter? An inverter is a device that transforms DC into AC. It varies the polarity of the DC signal approximately 60 times per second, simulating an AC signal. There are mechanical inverters that achieve a signal like this. How we can say this is an square signal. But this flow is very rough for an AC appliance, so electronic inverters are used that achieve a signal like this, too much similar to an AC signal. There are two types of inverters. True pure sine wave inverters, as the name suggests, true inverters transforms direct current into a smoothly varying alternating current very similar to the kind of genuine sine wave normally applied to our homes. They can be used to power any kind of AC appliance from a DC source, including TVs, computer, etc. And from the other side, we have modifier quasi-sine wave inverters. Modifying sine wave inverters use relatively inexpensive electronics, like thyristors, diodes, etc., to produce a kind of rounded off square wave, a much rounder approximation to a sine wave. And while they are fine for delivering power to hefty electric appliances, they can cause problems with delicate electronics like laptops, medical equipment, etc. And finally, in this picture, we can see the sine wave in purple, the square wave that the true pure sine wave inverters achieve in yellow, and the modified sine wave that the quasi-sine wave inverters achieve in green. So, I hope that you have learned anything in this presentation and you like it.